Could a lunar depot encourage the commercialization of space? What about in situ resources, making propellant on the lunar surface?
On the subject of lunar propellant and in situ resources that you hear talked about a lot, producing propellant on the moon, if you want to find out who's thinking about that, you might go to Shackleton Energy, created by Stone Aerospace. They're thinking of going to the moon, mining the soil for oxygen and other constituents for propellant, bringing it back to Earth orbit for sale to whomever at 1/10 the launch cost. That's their stated business case. The depot would buy propellant from the cheapest source. So if a depot is on the surface of the moon, the cheapest source would seem to be, very logically, in situ resources from the moon. If you're in low Earth orbit, it's almost intuitive that the cheapest source might be the Earth. It depends on the cost of producing on the moon, the cost of launching it, and how those launch costs play out against each other to get the cheapest propellant from the source, the moon or the Earth, into the propellant depot, whether it's on the surface of the moon, in lunar orbit, in Earth-Moon L1, or in Earth orbit. So you'd really want to buy it from the cheapest source. Other people have talked about going out to an asteroid or to Phobos or Deimos, the Mars moons, and getting propellant from there and bringing it back. The depot operator would obviously look for the cheapest source, and so it doesn't matter where it comes from as long as you get what you need. Keeping the propellant viable in space is a little more complex than shielding it from the sun. One can do it passively, that is, no mechanical systems, by just boiling off the hydrogen and venting that and losing that. Of course, you'd have to make that extra hydrogen up in the process of delivery. Another approach is to put cryogenic coolers or cryostats on the depot itself and have it mechanically keep the propellant cold. You'd have to have radiators to radiate the heat out into space, reliquefy the gases that have boiled off, or keep the liquid much below its natural boiling point for long-term storage. And that's one way to approach it, and that's what we'd like to do with the depot, is keep that boil off to minimum or to zero to minimize what you have to transport up. Another approach would be to transport water from the source to the depot. That makes sense from the moon to Earth-Moon L1 to transport water. You have you have full-time exposure to the sun for energy. When you're around Earth orbit, there's like a 2/3, 1/3 time. You're in the sun 2/3 of the time, 1/3 in the shadow, and you'd have to make up that nighttime process with batteries. So transporting propellant seems to me more logical. In Earth orbit, transporting water to Earth-Moon L1 would be more logical because of the power source, the availabilities. Transporting water is denser than transporting hydrogen and oxygen separately. So again, there are economies of doing it one way versus the other based on where it's going and where the depot is located.
Fuel depots in space may be nodes on a critical path to the moon. They will be force multipliers, enabling a more rapid habitation of space. I'm Emma with the Moon Society.